Okay, here we are. We got some people joining in. We will start in a few minutes, just giving everybody a chance to join. And while you're at it, if you can access the chat, feel free to post a message in there and say hi to people.
Yeah, I see more people joining, so while we're waiting, maybe I can start sharing our presentation already.
And let's just give it one more minute and give people a chance to join in.
Yeah, I guess for those who joined already, they can get a glass of water or a cup of coffee, tea, get comfortable for this 1 hour trip.
Definitely. Yeah, I still see a few people jumping on, so we'll just wait a little bit longer and then we will get started.
Yeah. Also, feel free to introduce yourself in the chat so that other people can know what's everyone's background.
Okay. Well, I am thinking we should slowly get started. As Benedetto just said, if you didn't hear him, feel free to introduce yourself in the chat. We've also learned right before starting that some of you might have issues accessing the chat. If that is the case and any questions come up, please feel free to send me an email at maria@ento.ai, and I will make sure to pass this question along during the presentation or afterwards. Do not hesitate with any questions that might come up. But briefly, just welcome to this webinar. My name is Maria, and I am hosting together with Benedetto, or I would say Benedetto is hosting mostly. He will talk a lot about IPMVP and how you can verify energy savings. For those of you who might not be familiar with Ento, we are a online platform that analyzes energy consumption and helps you find ways to reduce it. So you can log all your energy data and we will make analysis and we will tell you if there are any issues or problems. And based on that, we can also verify if you have actually made savings. And then Benedetto is one of the masterminds behind this feature. So I will actually quite quickly pass the word to him and let him do all of the talking.
Yeah, thank you very much, Maria, for the introduction. And yeah, welcome everyone to this webinar on IPMVP and how you can use it to verify your energy savings using our platform also, ento. And yeah, let's start by having a look at the overview of today's journey. I organized this presentation in 5 different sections. We're going to start by having a look at energy efficiency in general and one of the big problems of energy efficiency, and then we'll shortly present you a case study of how we measured savings in over 10,000 buildings in Denmark. Then we'll have a look at how we at Ento developed a measurement and verification product to verify energy savings within our platform. First, a small theoretical introduction, and then a live demo, and finally we'll go on with a Q&A session. And yeah, any question for those who were not able to access the chat, you can send it by email to Maria. So yeah, energy efficiency, I guess most of the people here will know the importance of it. In one of the latest reports by IEA in 2023, they stated that we can reach about 50% or 40% to 50% of the carbon reduction we need to be in line with the Paris Agreement just by implementing the right amount of energy efficiency. So definitely a very important topic, but there is few problems, and one big problem is that avoided energy consumption can be measured. What does this mean? It means that while, for example, for renewable energy technologies, which is one of the solutions that should go hand in hand with energy efficiency to reach our carbon reduction goals, we actually have some meters that can tell us how much we are producing, how much we are actually consuming in the building, if the local energy production is connected to a building, and how much we are injecting into the grid. This makes it really easy to do a pre-analysis of how much ROI is going to be driven by a certain local energy generation plant, and also to monitor after the implementation what are the savings that are being driven by a certain investment. In energy efficiency, of course, we don't have this because we cannot measure energy that is not being consumed. We don't have a meter that can tell us how much we saved, how much energy we didn't consume after a certain intervention. And this means that most energy efficiency projects today are actually based on deemed savings, which is actually just a nice way to say that it's some made-up savings that are coming from engineering calculations that are made beforehand, and we don't know if they're actually going to be reached throughout the course of the project implementation. So we have these two problems, which feed into a bigger problem, that is that if we want to reach the climate goals, we actually need to be accountable for the implemented projects that we are doing in our buildings. And this is commonly referred to in the field as measurement and verification of the savings. So how do we solve this issue? Luckily, we have a protocol which is called IPMVP, which is short for International Performance Measurement and Verification Protocol, which established some guidelines and a methodology that can allow us to estimate energy savings in buildings and in facilities, energy and water savings, actually. And the good thing is that this protocol becomes, let's say, the application of this protocol becomes easier as we are able to get more data with higher granularity from our buildings, and as we are able to leverage algorithms such as the machine learning or AI, if you want, algorithms that are able to process energy consumption. So how does this look like? How does this methodology look like? Basically, what we want to do is we want to establish a the normal state of functioning of our building before the installation period of this, a certain action that has been implemented. We want to analyze that consumption, and then we want to process that through a machine learning model, and in our case, and build what is called a baseline model that can predict an adjusted baseline energy, or sometimes called counterfactual consumption. This consumption is the consumption that the building would have had if there was no action that had been implemented in that site. So basically what we are saying is if on a certain date we did not change the parameters of the HVAC, we did not change the windows for more efficient windows, or we did not implement any intervention that we can think of for energy efficiency, then we would have consumed a certain amount of energy. But we are actually consuming a different amount, which is what we can see on the meter, and then the difference between this counterfactual or adjusted baseline energy and the one that we are actually metering is going to be the savings. So in this plot is quite clear. In this chart, we can see that first we have the measured baseline energy in the baseline period. This is the data that we study in order to define the normal functioning of the building. And then after the installation period, which is a certain period in which we are doing the renovations, we start predicting, thanks to our machine learning models, the adjusted baseline energy. And from there, we just calculate the difference. We have the savings. So how did we first implement this at Ento? It was not directly on our platform, but we actually received a task. We received a project commission from one large organization in Denmark, which manages municipal buildings, and well, the energy part of municipal buildings, and they basically asked us to verify if energy efficiency actions that had been taken during the energy crisis, so that is between October, September 2022 and the end of the winter, so February, March 2023. So several energy saving measures were implemented in municipal buildings in Denmark during this period. They wanted to know if they had an impact or not. So we said, yes, of course, we can do it. We have the way to analyze seamlessly, to integrate all this data from all of these buildings easily into our platform, and we can run these calculations. And that is what we did. For each one of these 10,000 buildings, we did what we saw in the previous slide, which was we calculated the baseline period and we projected the adjusted baseline during that winter. And from that, we estimated if there were savings or not in each of these sites. And then we aggregated the savings. So here we can see a little bit the results. I think the graph on the right is quite interesting, and it's the analysis of the whole portfolio of buildings. So we are talking here more than 70 municipalities, more than 10,000 buildings, and the height of the bars of this chart, we can see that it's the number of buildings that save a certain % of energy on their total consumption. So from what you can see, the distribution of these savings is skewed to the right, is moved to the right compared to the zero, and this means that as an aggregate, the whole portfolio saved energy. Of course, there are some outliers, some buildings that did not save, or some buildings that saved way more, but in general, like, the average of the distribution is skewed, and this means that there's been savings when we look at the whole portfolio of buildings. And another interesting result was that sometimes we say we can focus only on the biggest buildings, and that is going to drive most of the savings when renovating, but it's actually many small buildings that were driving the highest savings in this portfolio. So another interesting insight about this case study. So after this, we started thinking, okay, this was a very interesting project, and we're sure that many more municipalities and many more building owners would like to be able to do the same analysis we did, but on demand. So we started thinking, okay, can we implement this on our platform? And we started looking into the typical measurement and verification process. And the typical measurement and verification process in the industry has some pitfalls, and the main ones are that it's really a long process, a cumbersome process to collect all the data that you're going to need in order to perform the measurement and verification. Then you're not so sure about the data, and then you need to go on and do a manual analysis. You need to open an Excel sheet and spend many hours on that Excel sheet, trying to run formulas, etc. And then when the Excel sheet for some reason gets lost or gets corrupted, then you lost the results. And finally, many times you're not so sure about that result that you achieve. It's quite uncertain. It's not certified if what you are calculating in the Excel sheet is correct or not. So he said, okay, we feel like we have the possibility and the ability to improve on this. So let's try to do it. And yeah, basically it turns out that we are actually connected with utility data, which is actually the data that our customers are being billed with. So this is the source of truth. The data that we are getting injected into our platform daily is the real data that the customers are using. So there is no more long and cumbersome data collection process, because the data is automatically being injected into our platform day by day. We erased the manual analysis, because now you're able to, through our product, to launch AI-powered verifications within minutes through a very user-friendly process that we will show later in the demo. And finally, the results that you got, since they are following the IPMVP, which is an internationally recognized protocol, it's actually certified savings that you can know that they are actually trustworthy. So let's go a little bit and see how it works from the technical point of view. Also, I'm not looking at the chat right now, but Maria, if there's any question that needs to be addressed right away, please feel free to interrupt me. So how does it work from a technical point of view? We are using actually some tree-based models, and I'm not gonna get into the technical details, but just the three main reasons why we use these models is because they are fast, accurate, and interpretable, and we'll see more about that in the demo and in the next slides. Then another question that we get usually is like, how do you estimate how do you build the models? Which features do you use in order to predict the consumption? And so we are using hourly. We are trying to predict hourly energy consumption, so not at the daily level or at the monthly level, but each hour how the counterfactual or adjusted baseline energy would look like. And we are using these features, which are some weather features, such as outdoor temperature, solar irradiance, wind, and precipitation. Then we're using some calendar features, such as could be the hour of the day and the week of the year, but also holidays, bank holidays, or manual inputted holidays. And then finally, we're also using the COVID feature in order to not have the model confounded by this important event. But we're also aware that each building is unique. And this means that we implement a automated feature selection. So we let the model decide which are the actually informative features among these. We know that it's not the case that for every building, wind speed, for example, can have an impact. So we're only going to use that for the buildings where it actually makes sense. Some more short technical infos to not get spend too much time here. But one of the common issues when dealing with measurement and verification is that it's a long process and a manual process to define what are the verification periods. So that's going to be the baseline period. So before the action and the reporting period after the action. But we developed an AI-powered algorithm that is going to do that for yourself. And of course, you're always going to be able to override that if you don't agree with what you see. Then we also realized that in many cases, actions were implemented for a certain period of time, but then after that, there was maybe an increase in consumption that stopped the verification, because now the building is in another state, so it doesn't make sense anymore to keep verifying energy savings. Or on the other hand, there was another action implemented, and so it also doesn't make sense anymore, because you will be counting savings from both actions. So that is why we developed a technique to predict, even when the verified savings period is quite short, so let's say less than a year, to predict how much you would save in a year based on your concrete building, how much you would save thanks to that concrete action. And this gives us the possibility to compare different actions and their impact. And finally, we're also using this confidence level, 95% confidence level uncertainty ranges that are going to take into account the quality of the model to say how much uncertainty there is around certain saving that has been detected. And this is very important because sometimes the model can be not perfect, can not understand very well how a building behaves, maybe because we're missing important features such as the occupancy. And then in that cases, that is going to be reflected in the confidence level, and we can still believe the number that we see there. And just that we're going to see that in the confidence level, while otherwise, if we didn't do this, then we could never be really sure of the numbers that we are getting. On the other hand, when the model is really good and maybe a building is easier to predict, then we're going to get very low uncertainty ranges, and this is going to be better for managing risk, etc. So basically, what we want to say is that we have a trustworthy number out there, which takes into account the fact that a model can be better or worse in predicting energy for a building. Okay, so we made it through the first theoretical part, but I guess it's enough with the theory. As always, Maria, feel free to stop if there's any questions, and everyone, you can type in the chat, and but also send emails to Maria at ento.ai if the chat is not available for you. Okay, so let's have a look at how the product works. I'm gonna share. Okay. I guess you can see this. Maria, please interrupt me if it's not visible. But yeah, when you log into our platform and you go on the savings tab, this is what you're going to see. We wanted to give an insight into like kind of how reality is in our platform. So for this, for the first part of the demo, we are going to use some real data, real buildings, real savings from Hersol municipality, who kindly allowed us to show it to everyone, just to give a little bit of insight of how reality looks like when you are a customer of Ento and you want to verify your savings. So you get this overview on top of the page, which basically shows you year by year how your savings have been coming from specific actions that you've registered. So if you registered an action here, for example, here we have light optimization, settings of the ventilation systems, etc. Then we calculate annualized savings, even though we can't verify for some reason for the whole year, we still calculate annualized savings, and then it feeds into this depending on the year in which you implemented it. And then it all goes into the total annualized savings. This is the total amount that you've saved with all the efforts that you did during your history. And you also get a summary of that in terms of tons of CO2 avoided, the monetary cost This is about 4 million crowns. I think it should be something around 500,000 euros for those who are not based in Denmark. And then you also get, if you get water actions, you get a volume savings in cubic meters. Then you get this table. You can see different actions, the type of the action. We are currently supporting electricity, district heating, solar PV, water, and also district heating penalty. So the penalty that you are paying for not returning water at a certain temperature to the district heating company. Then here you can assign each action to a certain energy manager or responsible person. You can see if the action was positive, so if it actually decreased the consumption or not, how long that verification has been running for, and then you get the annualized savings. And finally, if you register some expected savings, if you're saving more or less than you expected, and also if you register the cost, you can see the payback time of that action. Plus you have some tags, which are some tags that you can give to each of the buildings, and if the building has those tags, then they show here, and some issues. Okay, so I guess we can have a look now at one concrete action. For example, we can open this one, and this is what you see when you open a concrete action. So the title, and then you go with the annualized savings and the total verified savings. In this case, since this action has been running, we were able to measure, to verify it for the whole 365 days. Then there is no difference between the total verified savings and the annualized savings. But let's say we were only able to verify savings for, let's say, 6 months, then we would get the annualized value here and the total verified here. Then you get a chart that shows you actually how your consumption looked like before and after the action. So the baseline period, the reporting period, whenever the action was implemented. And you can see also other actions that have been implemented in the same site. So here and here, and also periods that have been excluded automatically from the verification, which are the ones shaded in gray. So here we can understand a little bit better when we said like our AI-powered smart period detection. So basically what we are doing is by analyzing the time series of the building, we are detecting these orange segments, which is basically different modes in which the building has been operating in its history. For this site, we can see that we have 5 different modes. And basically we are using as baseline period the whole segment which was current when the action was implemented, and then the verification period is in order to stop the verification period, we have 3 different conditions, and we check for the first one that happens, which is either full 365 days of verification, or another action is implemented, or there is a change of segment. So let's say in this case, if we had, if this implementation was done, let's say 8 months into this verification, then we would have stopped it. But also if there was a change of segment, we would have stopped it. But since there was neither of these, then just by after 365 days, we stopped the verification period. Here then you get some summary about which are the dates for the baseline, the installation date, and the reporting period, for how many days this has been running, the annualized savings, and finally the total adjusted baseline consumption, which is basically the sum of the green line. So how much the building would have consumed in total if the action did not take place, and this number connects to this 32%. So basically this action is saving 32% compared to how much it would have consumed if no action had taken place. Another interesting feature is that you can switch between different granularities. So right now we're looking at the daily granularity, and by the way, you can also zoom in to see the different specific periods that we want to look at. And if you go on hourly here, you will get a a visualization of the hourly consumption, so you can know exactly at which times you are saving. For example, in this case, it looks like there's been a considerable savings, for example, at peak times, maybe not so much during the base load, but especially at peak times, we see large savings. And this can be really important depending on the action that you implement. You really want to know at what time you're saving, because that can have a different impact depending on the cost of electricity at that hour, or at the carbon intensity of the grid at that hour. Okay, so I think, yeah, we're almost done here. Yeah, then you have some small other info. If you input cost of service, then it would be here, and then we would get also return on investment and the meter type and the energy manager. Okay, but then when we started working with this, we were also thinking, okay, this looks like one side of the story, which is in a certain site, we can implement many different actions in a certain period, and we want to know the annualized savings in order to compare them, because we want to know which actions have had more or less effect on a certain site. So you want to be able to also know, like, when you invest money, which ones at an annualized level are giving more results. But at the same time, you might also be interested in the total performance of a building, which is kind of what we were tasked with in our 10,000 buildings project, right? So you want to know concretely a certain building in a certain period compared to a different period, how much they were able to save. And so we set out to do this, and we created a different feature, which we call the verifications. And here, basically, in verifications, what you're doing is you're not saying that you implemented any action, you're just comparing a baseline period and the reporting period. So you're saying, okay, in 2023, I want to know how much I'm saving compared to how much I was consuming the previous year, 2022. Or a baseline year, which could be 2021, 2019, depending on the report that you need to do. So many different reporting schemes have different baseline periods, and you can adjust it here according to your needs. So we can look at one here as well. For example, here this is for a concrete site, and this is district heating. The customer wanted to compare 2021 with 2023, and so you can see that in the whole year they were able to save 72 megawatt hours. Well, yeah, these are annualized savings, but total verified in 334 days, it's 60 megawatt hours. So this is also something that we allow users to do. We allow users to say, okay, I want to compare 2023 to 2021, and this will update every day until it reaches 365. So daily we get data in from your utility, and daily we update the verification and tell you how you're doing, and daily we update this. Also here you can go hourly and see at which times the savings were happening, similar to the other. Yeah, so how does it look like? Because as I said, we can do this on a single site, a single building, but we also wanted to give users the possibility to run this at larger level. So either at a single industry level. So let's compare all schools, let's compare all supermarkets, or we wanted to give customers the possibility to analyze similar sites by assigning tags to them. So for example, let's say I had a bunch of supermarkets that have been renovated in the same period. I want to analyze them together. I will assign them the same tag and then launch this verification on a tag. And this is what you can do when you register a verification. You can either select a site, concrete site, or an industry, depending on what you want to launch. Or if you don't select anything, well, you can also select a tag, as I said, but if you don't select anything, then it will run by default on all your sites. Okay, so now I wanted to go through the process of creating one verification, but I don't want to mess up also with the data of our customers, so we will move now to a demo user to create the verification. Yeah, as always, any questions, feel free to interrupt me. So this is our demo user. Sorry, getting my throat a bit dry. Yeah, we can register a verification now for one concrete site. This is a demo user, but all the sites are actually real sites that exist on our platform, just they've been anonymized. So for this one, we are going to use this Bank High Street Branch 3. And we want to compare, for example, the year 2022, well, 2023, compared to the year 2022 and see if there were any savings. We're going to run this on the electricity. I'm not adding any industry or tag because I already have my site. And then I need to define the baseline period and the reporting period. So I select the whole year 2022 as baseline period and the whole year 2023 as my reporting period. Then I can launch it. And when this gets launched, basically this calculation is sent live to our cloud computing platform, and we will get the results as soon as it's done back. I also have some verifications that I had already created here. For example, for all sites, I think there's around 40 sites for this organization. We could see that I first analyzed 2021 versus 2020, and we could see that there was actually an increase in consumption, especially now we can see it in the first part of the year. There was a base load increase, so we thought that the base load should be like this compared to the previous year analysis, but it was actually way higher, and this is why there is this total increase in consumption. You can see this has been run on 38 sites in total, and yeah, this has cost the organization 117,000 euros in total. But again, if you analyze all the sites, for example, 2023 versus 2022, you might be interested in tracking this year how you're doing compared to your previous year. And then there is, in this case, a marked decrease in consumption. So in this case, there's been, marked savings, which are increasing day by day, and you can use this to track the performance of your whole portfolio. Okay, let's also go now, while this is calculating, into a different demonstration, which is how you would go about registering a saving. So we can also even still work with these bank buildings, which are real banks that actually had considerable savings after implemented our platform, because they were able to detect some issues that their sites were not running optimally, and we were able to consider a decrease in their consumption. So this is this is what you would see if you were the manager of this building. This site was working with a total annual consumption of 58 megawatt hours before they realized that something was off, and then it was just an operational problem, no big implementation, no big investment. They just fixed the timing of the HVAC, which was running while the building was closed, and they got to 38 megawatt hours per year. So this considerable saving. Let's say they want to register it, so they can go here and they just say, yeah, I fixed the HVAC, and then I did it on a certain day, and then I said how much I paid for it. Here maybe it must be like almost zero, because they just needed to fix the set points, but maybe some service fee for the technical people. And then you can detect the periods automatically, which is what you would do by default. But if you, as I said before, if you don't agree with the periods that we automatically detect, you can uncheck this, and you can go with define your own baseline period, start and end, your own reporting period. If you did a renovation and there was an installation period in which the building was closed, you can add that as well, so that we don't take into account that data. And finally, if there's any outlier segment, any period that you want to exclude, then you can also mark this checkbox, and we will automatically exclude that outlier segments from the period that you selected. Okay, so I already created a couple of savings verifications for these concrete sites, just to show you how much they were able to save: 6,000 euros per year and 4,000 euros per year in the same site. First, just by fixing the operating hours of this building, they were able to considerably reduce the energy consumption. And then after that, they did actually an upgrade of the HVAC. They bought new motors, and that's again 4,000 euros just by doing this. And yeah, they did not register the cost of this investment, but we would get the return by just analyzing that if they did include it. Yeah, and as you can see, our AI-powered segment detection model works quite well. So it's able to say the building was working fine at a certain point, then something got messed up with the HVAC operating hours, starts consuming really high amount of energy. Then they realize, thanks to Ento, and it gets down to the normal amount again. And then after that, they do the HVAC operating hour, or sorry, the HVAC efficiency action, and it goes down again. Then here probably another issue started just this month that they should actually look at again. Okay, let's see if the verification we created before is done, and it is. So we created one for 2023 versus 2022 for this specific bank. We could see that in general the building already reduced its consumption considerably through the years. Probably, yeah, we can see that different actions have been implemented. And then, but this is just a verification. So in 2023, we want to know how well we are doing compared to the previous year. And this allows us to do exactly this, to track the individual building. And yeah, and then at the same time, if you're interested in our whole portfolio, then we can register a verification just for all sites. Yeah, I think that's been a lot of talking. I hope, yeah, it was informative. I hope it was clear for everyone how this work, and if this can impact your organization and make it easier for you to report and to get insights into your savings, into your building. And I guess now we are going to open our question and answers section.
Yeah, I'm gonna jump in. The first question is not so much related to IPMVP, but more if we offer an API to other software vendors, if this is something Ento is doing. And I don't know if you want to answer that one, Benedetto, or you want me to do it. Take it.
You can if you want.
Okay.
Otherwise, I can.
This is not something we're doing right now. To answer your question shortly, Mike. Yeah, so the next one we have is, how do you extrapolate annualized savings from shorter time periods? Is there a minimum duration to be able to calculate annual savings?
Yeah, so there is no minimum duration. Of course, the quality of the prediction can gets better, because we are trying to predict the rest of the year. So if I'm trying to predict 11 months, it's different than if I'm trying to predict 3 months. But in general, what we are using is like the overall consumption of the building. So also the adjusted baseline consumption, and depending on how much savings we were able to detect in a certain period, and knowing more or less, being able to predict more or less how much consumption is missing, let's say, in the period that is missing, and how much savings we can expect on that consumption that is missing. That is how we then extrapolate to annual savings. So basically, to answer in a bit shorter way, we are using the the consumption, the real consumption of the building that we are able to analyze, and the savings that we already achieved, and then extrapolate that according to how much consumption we think, or we predict, is missing for that building. And yes, of course, as I said, there is no minimum, but as you increase the amount of days that have been already verified, then the uncertainty in that prediction decreases. Hopefully that's clear enough. Otherwise, I'm clear. I'm happy to go more deep into the technicalities.
We'll leave it for there, and then I will let people jump in and let us know if they want more specific. We have another question. How do you manage an action that saves both district heating and electricity? Is this process automated?
Yeah, so it is not automated right now. So right now what you would need to do is create two actions, one on a district heating meter and one on a electricity meter. But the idea is that in the future you will be able to select multiple meters when you create an action, and that will automatically launch as many verifications as are needed. But yeah, this is for future version. We have in store a lot of improvements to this tool, which we just started building a few months ago. But yeah, we're really excited where this is going and where it's going to evolve in the next months.
Okay, well, please feel free to ask any more questions. In the meantime, you said that we have some improvements in store. Could you elaborate a bit on that, Benedetto?
Yeah, I think I even had a slide for it. Let me see if I can find it. Yeah, so the main ones that we are thinking about right now, but this is also very fluid depending on what we get from the customers, like the requests we get with the customers, because we really just like to follow both our ideas, but also like the feedback we get from the customers. So the platform is live, and as we get feedback, then we improve on it and we decide what we're going to do next. But the main things that we have in mind are expanded info for aggregated verifications. And this is basically that right now we are only able to see how many sites and how much you saved in total when you open an aggregated verification. But the plan for the future is to include more graphs, for example, the portfolio graph that we saw from our case study, and also to be able to know exactly which sites are saving how much. So which are the sites that are most contributing to this aggregated savings, and which are the ones that are maybe left back. And this should also help customers in detecting the ones that actually need they need to focus on and that they have issues. So we're excited to release that. Then we also want to release model inspection to get into the results better. So this means that you will be able to see for a certain verification. This is more like for the more technical people that want to really get into the insights, that want to understand more their buildings. Basically, you would get into the verification and would be able to see which are the features which are driving most of the model importance. Yeah, the features that have the highest model importance, and that means if a building's consumption is actually being driven mostly by, for example, weather, or most by more calendar features, or if how important, for example, is COVID, and this, or if we use any feature at all, because as you said, we don't use the same features in all sites. And this is also going to be just an aggregated importance for all features, but even you'll be able to see hour by hour how much was the contribution of each feature. So this is I think it's really great, and it's going to help the more geeky energy managers to get deep into the results that we provide. And finally, we have this another thing that we think is very important, and it's been requested more than once. So we already calculate hourly savings, so savings at each hour. But what we want to do is to be able to match. Right now, we are matching that with an average electricity price and an average grid carbon intensity for the certain source. But what we want to do is to start to be able to match this hourly savings with the hourly price that you get from your utility and the hourly carbon intensity that we're getting from the grid live through different and software solutions that now exist in this field. So we think that this is also going to be really important, because it's not the same to save a kilowatt hour in the middle of the day when sun is shining really strong, than save it maybe during the night when we need to activate a coal power plant, depending on the location where your sites are based. So we think that these three are going to be the big ones. But as I said, any customer request that we get that we think gets higher, like can provide higher value than this, it will also be introduced into the development.
Well, we got some clapping hands for that, so that's good to know. We got some other questions that came in. If multiple actions have taken place within a short time period, how do you assure they don't overlap in the savings?
Yeah, this is a really good question, and it's one of the main issues that we've been battling with since we implemented this tool. The reality is that there is no easy way to do this, because even as you can think like in a logical way, when you implement an action and then you implement a new action, maybe let's say 1 or 2 months after that, then we don't like our new baseline should just be those 2 months, because that's a new state of the building. But if we just implement a baseline of 2 months, we don't really know how the building behaves in general, because we basically we're missing big part of the year, so we can't understand the seasonality. If, for example, those months are in summer, we don't know how the building works in winter, etc. So on the one side, what we do is we stop the verification whenever a new action is implemented, so that it can solve part of the issue, because we are not verifying many actions together. But the other issue is also with the baseline field. And then in that case, there's different solutions that can be implemented. One of them is merging multiple actions together. So if your actions have been implemented within 1 or 2 months, then maybe it might make sense to just merge them together and say, I did this and this in the last month, put the time in between as installation period, and just take before and after those two actions together. You're not going to be able to get individual savings for one individual action, but you can trust that the sum of the impact of both is going to be what we show. But we are also working on different, let's say, R&D methodologies in order to address this issue. We want to do more to be able to not force our customers to join their actions together, and still leverage all the data that we have, because we have a lot of data from the buildings past, and still be able to understand both how the building works and let's say the impact of a recent action. So we are testing different things, and we think that that we can give something new and new completely in the field, I would say, because I mean, I've worked in this field for quite a bit. I wrote a PhD thesis on measurement and verification, so I can state that in research or industrial organization right now, there is a very good way to define a baseline period when you implement several actions within a few months. And the typical answer that you would get from IPMVP might be just to either just choose one that you want to verify, or to typically define properly your baseline period before, and make sure that is not impacted by any other action. But again, if the only baseline period that you get is few months long, 1 or 2 months long, that is really difficult. But yeah, advances in AI and research in this direction, I think we can get new solutions to this.
Cool, thank you. We have another question on what type of machine learning algorithms do you use in energy consumption predictions when building the energy baseline model?
Yeah, so we are using gradient boosting machines, which, as I said previously, it's a tree-based model. And we are using that because what's been seen in research is that it's the best algorithm to deal with tabular data, and especially there's been a world competition on predicting energy consumption on Kaggle, which is one of the leading energy consumption analysis, one of the leading data analysis, data science competition platform. And this competition was on energy data, and all the winning solutions used gradient boosting machines. It's a very good algorithm that is able to take into account the non-linearities of how the different features impact the energy consumption. Plus it's really fast, and through different techniques you can get quite interpretable results, which is not always the case when you deal with more complex algorithms such as deep neural networks, for example.
Okay, thank you. Then we have a question going back a little bit to the hourly price. Does it include shipping price, and how do you plan to handle the different price structures from different utility companies, and can you handle tax deductions?
Yeah, so we are currently implementing this, and I think this will depend on, like, we already have custom integration for different utilities in different parts of the world, and different contract structures depending on the customers, and this will just have to go into that work, let's say. So whenever we onboard a new customer, we can understand which utility they're working with, and then from there we just define their contract. That goes into our database, and then automatically whichever new verification happens, or whichever new potential for savings we detect with their building, is going to already take into account the hourly price and the shipping price, and whichever special feature your contract might have, which cannot be handled easily, let's say. But yeah, that is, let's say, part of our onboarding process with customers.
Cool. Well, I don't see any more questions coming in. Please do feel free to add them. I know that there are some people here who already are using the platform, but if you're here for the first time, also please feel free to reach out if you want to have a test of your data for this verification tool. We do have a question coming in. Which types of buildings of which the measurement and verification results were not accurate?
On which type of buildings the results of measurement and verification were not accurate?
Yeah.
I guess there is no specific type. I guess it depends more on the specific building. So there can be times where usually what we are trying to do is to explain the consumption time series of a building based on a list of external features. But many times we don't have access to all the features that are having an impact on a certain building. So let's say for one building, it might be really important to know how many people are in at different times, because maybe they don't have predictable. Usually we use calendar features as a proxy for this. So we say if it's a Monday, then we know that more or less this is going to be the people, and if it's a Tuesday, and if it's 12 a.m., and if it's 3 p.m., etc. but some buildings might have irregular patterns of occupancy. And then in this case, when we use our calendar features as proxy for this, then doesn't work so well. In this case, the model will behave poorly. We wouldn't be able to predict so well the energy consumption, and then you will get a high uncertainty in the savings. But I have to say that with most of the buildings that we deal with that are like tertiary buildings, so it could be offices, it could be supermarkets, it could be banks, many different kinds of buildings. Usually our models work quite well without having access to the occupancy feature or other features which might be hidden.
Okay. Yeah. Well, I think we're happy to hang for another minute. If any questions come up, please feel free to add them. Otherwise, this is pretty good timing in terms of an hour coming in. And yeah, as mentioned before, if you don't already have your data on the platform, you can reach out, send us an email, book a demo, get your data on the platform, and you can test out these verifications. So please don't hesitate to reach out. You can contact Benedetto and I. You're also welcome to contact our sales team if that makes more sense. Whatever works for you. Otherwise, I think we're gonna say thank you so much for joining. I don't know if you have any final words, Benedetto, you want to end the presentation with?
No, yeah, that's incredibly on time, so really good for that. And yeah, I hope it was, as I said, informative for everyone, and that yeah, just feel free to reach out if you want to know more about the technical part. I'm always into having this kind of conversation. So you can reach out. You have my email. It was at the beginning of the presentation, but you can also reach out on LinkedIn. Yeah, you can find me with the name and surname.
Okay. Well, thank you everyone for joining, and hope you enjoy the rest of your day. Bye.
Yeah, thank you. Bye.